So this is a continuation. This is the continuation of the previous lecture, and we already discussed the basic definition of a linear system and condition check to check the linearity. And in the previous lecture, we already discussed some problems. Basically, the continuous time signals up to y of t is equal to e raised to x of t we discussed in the previous lecture. Now we'll start from this particular problem. Y of t is equal to integral minus infinity to t x of tau d tau. And some discrete time signals. So this is the first question. Here the input output relation of a system is given by y of t is equal to integral minus infinity to t x of tau d tau is actually an integral uh, system, integration system, and we need to determine whether the system is linear or not. In order to check the linearity, we need to use this condition. We need to verify this condition. Ax1 of t plus bx2 of t, whether it gives ay1 of t plus by2 of t. So we need to verify it's a continuous time signal. So we need to use this equation. Or you can call the weighted sum of inputs to the system produce an output which is equal to the weighted sum of outputs. Weighted sum of inputs produce weighted sum of outputs. Then it is known as a linear system. Let's assume that for the input signal x1 of t, the system produces an output y1 of t. And this is system. Okay. This is system, and the input is if x1 of t, the system produces an output y1 of t. And this y1 of t, I can write in this particular case, this y1 of t is equal to integral minus infinity to t. Here it is given if input is x of t, it's x of tau d tau. So you can write x1 of tau d tau. So this is y1 of t. And if the input is x2 of t, the output is y2 of t. So you can write it is y2 of t is equal to integral minus infinity to t x2 of tau d tau. Okay. Now we can consider third input, okay, which is x3 of t, and assume that the corresponding output is y1 of t. Sorry, y3 of t. And this y3 of t I can write like this, integral minus infinity to t x3 of tau d tau. And assume that the x3 of t is a special type of input, which is a sum of the two inputs x1 and x2, and it's a scaled version. Then you can substitute this x3 of t in this particular equation. Then you can write y3 of t is not equal, it gives, okay. Y3 of t can be written as integral minus infinity to t. In place of x3 of t, you can substitute this particular equation. So it becomes ax1 of tau plus bx2 of tau, okay, into d tau. And I can split this integration. So it becomes a into integral minus infinity to t x1 of tau d tau plus b into integral minus infinity to t x2 of tau d tau. If you compare the expression minus infinity to t x1 of tau d tau is actually our first equation, that is y1 of t. So in place of this expression, I can write simply y1 of t plus b into the second term is actually the y2 of t. So you can write simply y2 of t. So for the given input ax1 of t, okay, ax1 of t plus bx2 of t, that is a weighted sum of inputs. You are getting output as weighted sum of outputs. So we can call it as the system is linear. So we can verify that the output is a linear combination of output a y1 of t plus b y2 of t. So we can call it as this system is a linear. Okay. So the system is linear because it's obey the weighted sum of inputs equal to weighted output. Or we can write the statement ax1 of t plus bx2 of t gives a y1 of t plus b y2 of t. So that's why system is. So integration system uh, integral system is a linear system. So integration operation is a linear operation. Okay. Now we'll check the next question. This is a discrete time signal. The input output relation of the system is given by y of n is equal to n square into x of n. That is, if you are applying any input for the discrete time system, this is a discrete time system, and the input is x of n, it produces an output which is known as y of n and can be written as n square into x of n. So that is given actually. If you apply x1 of n, the output will be n square into x of n. And this is a discrete time system, so we need to verify the second equation. A x1 of n plus b x2 of n gives whether it gives a y1 of n plus b y2 of n. So assume that let an input x1 of n produce an output y of n. So we can write y1 n can be written as n square into x1 of n. Okay. Similarly, the second input x2 of n, the output is y2 of n. You can write y2 of n is equal to n square into x2 of n. Assume that there is a third input, that is x3 of n. Okay, and this y3 of n produces an output. Sorry, x3 of n produces an output y3 of n, which is equal to n square into x3 of n. And assume that this x3 of n is a linear combination of inputs. So x3 of 3 of n can be written as a x1 of n plus b x2 of n. So this is a linear combination of two inputs. And corresponding output y3 of n you can check. So in place of x3 of n, you can substitute this equation. So you can write n square into, in place of x3, you can substitute this equation. So x3 is a x1 of n plus b x2 of n. So your equation becomes, if you rearrange this equation, n square, there is an a n square x1 of n plus b into n square x2 of n. And if you compare with the previous equations, that is y1 of n and y2 of n, you can substitute here. So the term n square into x1 of n is equal to y1 of n from the first expression. So you can write a into y1 of n plus the second term n square into x2 of n can be written as y2 of n. So you can write b into y2 of n. And you got output as a linear combination. So here you can see that the input is a weighted sum of inputs, and output is also the weighted sum of outputs, or you can call it as the system is linear. So the given system is a linear system. Okay. Now we can check next question. Here the input output relation is given by y of n is equal to 3x of n plus 5. So based on the previous expression, we know that this is a discrete time sequence, so we need to verify this equation and assume that the input x1 of n produces an output y1 of n. So y1 of n can be written as, if input is x of n, you need to write 3x of n plus 5. So this is x1 of n input, so you can write 3 into x1 of n plus 5. And similarly, for the second input x2 of n, the output is y2 of n, and you can write the expression like this: 3 into x2 of n plus 5. And you can consider third input x3 of n, and the corresponding output is y3 of n, and y3 of n can be written as 3 into x3 of n plus 5. So this is the third output, and we'll assume that the x3 of n is a linear combination of x1 of n and x2 of n. So you can write x3 of n as a combination of the two inputs, a x1 of n plus b x2 of n. Now in place of x3 of n, I can substitute this expression. So the y3 of n become 3 into a x1 of n plus b x2 of n plus 5. And if you rearrange this equation, you can see that this is a into 3x1 of n plus b into, again there is a 3x2 of n plus 5. And if you rearrange this, it becomes a y1 of n. If you group this, a into, if we take, sorry, you cannot write like this, because y1 of n is equal to 3x1 of n plus 5. Okay, so this a is not common for 5, so we cannot write like this. So which is not equal to a y1 of n plus b y2 of n, which is not equal. Okay, if you want to write y1 of n here, it should be 3x1 of n plus 5, but here it is a into 3x1 of n. There's only one 5. So if you want to write y1 and y2, you required 5a and 5b in this particular expression. So we cannot write like this. So the weighted sum of input, okay, here it is a weighted sum of input, it's not a weighted sum of outputs. Okay, so the system is non-linear, or you can write a x1 of n plus b x2 of n not equal to uh, not is a y1 of n plus b y2 of n. So the system does not obey linearity property, so system is non-linear, because we cannot group it is a into y1 of n form. Now we'll see next question. Here it is given y of n is equal to x of n into cos omega n, and again it's a discrete time system, so we need to verify this particular equation. For the input x1 of n, the output is y1 of n, so you can write y1 of n is equal to x1 of n into cos omega n. That is, this particular system, if you are applying x of n as the input, it produces an output y of n, which is simply the product of input and cos omega n. It will multiply with cos omega n into x of n. So this will be the output. And for the second case, here it is x2 of n into cos omega n. Now we'll consider the third input, x3 of n, and it produces an output y3 of n, and y3 of n is equal to x3 of n into cos omega n. And in this particular case, x3 of n is the linear combination of two input. X3 of n is equal to a x1 of n plus b x2 of n. Now x3 of n is defined as a x1 of n plus b x2 of n. Now we can substitute x3 of n, the previous equation. In place of x3 of n, you can substitute this expression. So you'll get a x1 of n plus b x2 of n. If you substitute here into cos omega n. Now we can expand this after multiplication. So a x1 of n into cos omega n plus b into x2 of n into cos omega n. From this particular expression, you can identify that x1 of n into cos omega n, you can write y1 of n. So y A into y1 of n plus b into y2 of n. And if you compare with the standard equation, the input is a weighted sum of inputs a x1 of n plus b x2 of n as a linear combination of inputs. Output is also a linear combination of output. So it's a weighted sum of outputs. So we can conclude that the given system obey linearity property, and we will call the system as linear system. Now we'll check another question. This is another question. Here again, discrete time system. Y of n is equal to x of n plus 1 by 3 x of n minus 2. Okay. The given equation is given as a difference equation. Some delay elements are there. Again, it's a discrete time system, so we can apply the linearity. This to check the linearity, we can use the discrete time equation. And the first case, if the input is x of n, the system produces an output that is given by y of n, which is x of n plus 1 by 3 into x of n minus 2. Okay. So in this particular question, we can write, you can check the condition in two different methods. Here, for the input x1 of n, the output is y1 of n. We can write y1 of n is equal to x1 of n plus 1 by 3 x1 of n minus 2. And for the second input x2 of n, the output is y2 of n, and the y2 of n can be written as x2 of n plus 1 by 3 x2 of n minus 2. And you can consider the third input x3 of n. For the input x3 of n, the output, the corresponding output y3 of n can be written as x3 of n plus 1 by 3 x3 of n minus 2. And assume that the third input x3 of n is equal to a x1 of n plus b x2 of n as a linear combination of two inputs. And you substitute in place of x3 of n, it becomes, you can write y3 of n is equal to a x1 of n plus b x2 of n, okay, in place of x3 of n, plus, and in place of 3 x3 of n minus 2, you can write like this, 3 into a x1 of n minus 2 plus b x2 of n minus 2. Okay. And if you compare this particular equation, this should be written as a y1 of n plus b y2 of n. Okay, you need to write like this, a y1 of n plus b y2 of n. But if you write a y1 of n plus b y2 of n, it will be like this, a into x1 of n plus a by 3 x1 of n minus 2 plus b into y2 of n should be like this, b into x2 of n plus b into 3 into x2 of n minus 2. And if you compare these two equations, and this y3 of n, okay, this y3 of n and a y1 of n plus b y2 of n, these are different. We cannot group this y3 of n, this particular combination, a y1 of n plus b y2 of n. So we can say that this is not equal to a y1 of n plus b y2 of n. Okay. So the system does not obey the linearity property. So this is not a linear, it's a non-linear system. So we can conclude that the given system is non-linear. And you can approach this particular problem similar to the differential equation. Here you can apply the difference equation concept. If you group this particular time, again, we cannot write this in the weighted sum of inputs equal to weighted sum of output. So we can conclude that the given system is non-linear.